Hello and welcome. Today we're going to be looking at another example of an application of calculus to study problems in business. So we're going to be talking about an optimization problem in business. And the specific one we're going to talk about is the economic order quantity. Okay, and we'll describe what this means, but this is one of the classical business problems involving buying and selling and basically inventory management. So inventory management being a critical part of essentially buying and selling things is basically the idea here is that you're a business and you sell units of stuff. Okay. And then what you do basically is you buy it from a manufacturer, or you could be the manufacturer yourself and you're actually producing it, but you're going to buy it from a manufacturer, let's say, and then you're going to store it in a warehouse. And so the idea here is maybe there's some factory, there's a smokestack. I'm just kind of drawing a little silly picture here. And they make widgets. Okay, so you come out and you get a widget and it goes into your warehouse right here. There's the warehouse doors. And it goes in there. And inside your warehouse, you've got pallets and pallets of widgets. Okay, so that's in your warehouse there. And then, of course, on the other end of your warehouse, you take orders. And those widgets go into a truck, and you sell them and you send them off, and then of course you make money from those things. So the big question here is one of inventory. And the big question is how many should we store in the warehouse? And that's a big question that we might want to have. All right, so how big does your warehouse need to be? Warehouses are expensive. Maybe you have to heat them. Maybe you have to light them. You have to pay people to be in them and to have forklifts and all of the things that you might costs associated with it. Basically, storing stuff in order to sell it. So let's come up with a few basic definitions. So we're going to talk a little bit about the goal here is to minimize the total cost of inventory. Okay, and what we have control over is basically how much do we order at a time, given a fixed demand. Okay, so demand is basically how much widgets you typically sell. And you could do that per year or per whatever period of time, or, whatever year of time, whatever amount of time that you're interested in studying over. But we'll just say per year. Okay, so let's say we have a good understanding of how much we're selling, but we want to know how much we want to keep in our warehouse. on hand all the time. Of course, once the warehouse gets pretty empty, of course, we're going to go make another order to the factory. Okay, and then so basically we'll order the order size. The order size, what we're going to call Q, which is the quantity we're going to order, is a variable we will decide on or control. All right, we want to use that variable, and we want to control that to see if we can minimize costs. All right, so let's come up with a few definitions here. So the first is going to be the price, which is the cost. Well, actually, let's do this on the next page. Okay. So let's look at the costs associated with inventory. Okay, so first we'll have TC, and that's what we call our total cost. And the total cost is comprised of some other subcosts. P, which we're going to call basically the unit price. Is a price per unit, so it's just how much it costs to order one unit from the factory. Okay, Q is that order quantity. Okay, and that's basically how many widgets do we order each time. Okay? Of course, this is in dollars, and this is in number of widgets. Okay, so those are the units there. Okay, and then there's D, which is the annual demand. Again, that is going to be in the units, number of units sold. Okay, and then the next cost is going to be K, which is going to be the cost per order. Okay, so the cost per order is a fixed cost of just making an order. For instance, to call up the factory to even create an order sheet, maybe to hire a truck to transport the stuff from the factory to the warehouse, those are all fixed things that don't necessarily depend on the number of, it's a fixed cost, not per unit. Okay, so obviously the unit price is the cost per unit, but this is another cost that's tacked on in addition to the unit price, and that might be a shipping cost, something like that. Okay, and then there's another cost which we'll call H, and that's the holding cost per unit. So per unit holding cost, and that's basically the cost to keep it in your warehouse per day or something like that. Okay, so putting all this together, what we're going to say is the following. Okay, so the scenario we have here is basically over time you're selling stuff. So you know that the demand, basically the amount of orders you get per day or per year, is going to be whatever it is. It's going to be fixed, and this is going to be your inventory each day, and that's going to go like this. You make an order, and you're going to order Q of them, and all of a sudden your warehouse is filled with Q things. And of course, slowly over time, you keep filling orders and sending them out to customers, and then when you get down to none left, you make another order, and you go back up Q again, and then you go down like that. And then once you get to 0, you order again. You get Q of them, and go like that. So of course, Q is that variable. That Q is the thing we want to determine what's the right amount to order. Okay, you can imagine in a different scenario, if Q were a different value, maybe you order fewer of them, and it would be like that. Okay, you'd make more orders over the course of the year, like that. So it depends on how many orders you make per year. So of course, but here's a typical thing that's going on. So if K is big, okay, so the cost per order is very big, you'd expect you'd order more. So you expect Q to be big. Okay. You'd expect that if H is big, right, if the holding cost per unit is big, you would want Q to be smaller. Because you don't want to order a whole bunch of them having sitting in your warehouse for a long time before you've sold them all. So these are basically the general business logic that we have put into this thing. Of course, you could look at other things as well. So those are the basic variables of what's going on here. All right, so now let's put together all of these variables and come up with an idea. So the goal here is to minimize the total costs. Okay, the total cost, though, is comprised of several things. One is, and maybe this is per period, or maybe it could be years, a year or something like that. So we know that the demand over the whole year, and we know that there's going to be the price of purchasing all the things. So this is the money you pay the manufacturer to buy the amount that you expect to sell. Okay. In addition to that, of course, we also have cost for the order. So we have that cost for that for the order times the number of orders. Okay, and we'll come up with an idea of what that number is. And then in addition to that, there's also the holding cost, which is H, which is the holding cost. And that has to be multiplied by the average number on hand in the warehouse. Okay, so number of orders. The number of orders has to be basically related to D and Q. So basically, if D is the total number you're selling and you're ordering Q of them per order, then if I divide it by Q, that gives me the number of orders I'll make on average throughout the year. Okay, so that'll be the number of orders. And now, what about the average number on hand? So recall that graph I showed you before. If I make an order of Q and then it runs down and it goes up like that and it goes down again and it goes up to Q again and then you sell off till you get to 0 and then you order another Q and so on forever. I want to look at what the average number I have on hand, and that's going to of course be, you just split that line right there. So it's really going to be 1/2 of Q, basically, is the average number on hand. So that's going to be Q over 2 is the average number on hand. Okay, so you imagine if you order a larger amount, on average though, half the time you're going to have more and half the time you're going to have less. And so if Q is the total number, then Q over 2 is the average number you're going to have on hand over the course of many cycles of ordering and selling and ordering and selling. Okay. All right, so put that together. Total cost is then going to be demand times the price for each unit plus K times D over Q plus little h times Q over 2. Okay, all right, so now we want to minimize. So let's just look at the graph of this function. Clearly, you can't make 0 you can't order more. You can't order less than one item. But we'll put a graph here. Looks like that. But in general, the graph is going to have this shape. That's going to give it an inverse, and that's going to give it a linear component. And that's going to be the inverse component. Put those together, and you're going to get a curve that looks like this. It's going to have that inverse component, but then ultimately, as the inverse component disappears, it's going to go up and then become basically linear with slope h over 2 right there. Okay? But there should be some point right there, which we'll call Q star, which is the amount you should order, and that's going to give you the minimum total cost. All right, to find that minimum total cost, all we have to do, of course, is use our standard standard derivative trick, which is take the derivative. Okay, we're taking the derivative with respect to Q. That is the variable that we have, that's the independent variable, the thing that we need to choose. So everything else is going to be a fixed constant, so that the derivative of d times p is 0. The derivative of kd over q is going to become negative, it'll become negative kd over q squared, and that's the derivative of that term, plus, finally, h over 2, derivative of the linear term. Now we're going to set that equal to 0, and we're going to get the following formula. We're going to get, we'll have that h over 2, multiply everything by q squared, and then we're going to get kd on that side. And then we're going to get 2kd over h is equal to q, and then we have to take the square root, of course, to get rid of that square. And that's going to be my q star. That'll be my optimum point right there. And let's just check this out really quick, all right? Let's make sure this makes sense in terms of what we expected. If the demand is higher, we expect the amount we order should generally go up. If the cost per order is bigger, we expect also that we're going to order a larger amount, because that's a fixed cost we can't get rid of. So if you're going to make an order, you might as well stock up, essentially. But if the holding costs are very great, we know from on the previous page that the holding costs, if they were very big, we'd expect that we were going to order few of them per order. So it has to do with that ratio between the fixed cost of ordering and the holding cost of inventory. The ratio of those is ultimately what determines the economic order quality. So this is what they call the economic order quantity, EOQ. And it is one of the classic examples of using calculus in a business context for managing the orders in a context of an inventory management system. Of course, there are so many other things in business that involve calculus type tools. This is just but one simple example used all over the place. Thank you very much.